The next section in our stats unit is about box and whisker plots, which I think that you've made box and whisker plots before now. But we'll brush up on any skills that you have or make sure that you understand it. So in a box and whisker plot, there are some common misconceptions. Now, the lowest value is at the end of the left whisker. The highest value is at the right end. That's the maximum, the minimum, okay? The median, the middle number, is represented by the middle bar inside this box. The mean is actually nowhere in a box and whisker plot. Nowhere. Also called a box plot, okay? And that is one of the common misconceptions. So this marks the 50% of the data falls below it and 50% of the data falls above it. Okay, so that's the median. Now, if you were to take the bottom, let's look at this. So if we look at this set of data points here, 68 is the median. It's the middle value. Okay, 1, 2, 3, 4, 5, 6, 7. There are 7 below it and 7 above it. Now, if you don't include that value, then you find the median of the lower half, and that gives you what's called the first quartile, Q1, the first quartile. So in fact, you're finding the median of the entire set, then the median of the bottom half is the first quartile, and then, so that was 52, so that's here, okay? And then you find the median of the top half, and that is 87, and that marks the right side of the box, okay? So we've got the minimum, the maximum, the median, then this is the first quartile, which is the median of the bottom half, and this is the third quartile, which is the median of the top half. Now the median is also called the second quartile, because if you think about it, we're dividing it into 4 quarters. 25% of the data falls below the box. 25% of the data falls above the box. And 50% of the data falls within the box, where 25% is below the mean and between the first quartile and the median. So between the first quartile and the second quartile. And then 25% of the data falls between the second quartile and the third quartile. Okay? And so these values are called the 5-number summary. So you got your your minimum, your maximum, and each of the 3 quartiles. Now, one other thing is that the range is the high minus the low, the max minus the min, which we're familiar with. But this a box plot allows us to find the interquartile range, which is also sometimes written IQR, interquartile range. And this is actually a better descriptor of the variance or the variability of the data, because it doesn't include the maximum and the minimum, and those might be outliers. So this is a more sophisticated way to check variability, is the interquartile range. So now that we know how to find the interquartile range, we will use that to talk about the spread of the data and not so much the range, unless it specifically asks you to find the range. So let's do some examples. Answer the following questions given the double box plot below that shows test scores from 2 classes. So one of the great things about box and whisker plots is that you can do comparative box plots, or a double box plot as it's called sometimes, and you can see how the 2 classes or how the 2 things or sets of data compare to each other. And with them right next to each other, it becomes a very good visual of how everything lays out. So what is the median score for each class? Okay. What we'll do is I will do class A, and then you can go back and do class B. So if we've got class A here, I'll do A with you. This one asks for the range of each class. This one asks for the interquartile range, and then we'll answer these other questions. So the median, remember, is just the middle of the box. That says that 50% of the data falls below it, 50% falls above it. So in Class A, the median is 77. Okay. The range for Class A, now this is just asking for range, so you're going to take the high value, which is 85, and subtract the low value, which is 70, and that means the range is 15. Okay. And then now the interquartile range is the range of the box. So this is the interquartile. We want to find the range of the interquartile, I guess. And so it's similar to this, but we only use the far right of the box and the far left of the box. So we would do 82 minus 73, which gives us an interquartile range of 9. Okay, so of course the range is always going to be bigger than the interquartile range, because the range isn't going to include your extreme highs or your extreme lows. It's going to include every single data value. But when we're comparing them, the interquartile range is the one that we're going to use to compare. Okay, so I want you to pause the video, and I want you to do the second half of this. Find the median for B, find the range for B, and find the interquartile range for B. I also want you to answer D and E with your partners as well. So I want you to finish up A through E as best as you can, and then we will go over those questions. So go ahead and pause the video now. Okay, let's see how you did on this. So the median score for Class B should have come out to be 80. The range for Class B would be 93 minus 72, which is 21. And C, the interquartile range for the scores would be 87 minus 73, which would be 14. So let's finish up with D and E, and then we're going to talk about a couple things. For Class A, what percentage of scores lie between 70 and 82? So 70 is here, and 82 is here. So if this marks the first quartile, and this marks the second quartile, and this marks the third quartile, this is 25%, 25%, and 25%. So what percentage of scores lie between 70 and 82 would be 75%. And for Class B, what percentage represents the 25th percentile? So for Class B, the 25th percentile would be right here, 73. Oopsies, sorry. Now, I want to talk about interquartile range and range. Now, we know that the range tells us the spread of the data. So the one that has the largest spread, if you're just looking at range, is of course Class B. Okay, it spans further. Now, if we look at the interquartile range, we still see that Class B, even in the interquartile range, is spread out much more than Class A. So what does that mean for these two classes? That means that Class A, Class A's scores are more consistent. And Class B has more variability, meaning that the scores in Class B have, there's a more chance that they will go further above or further below the median. The spread of their scores is much bigger. Okay. All right, let's move on to the back side and try some other examples here. The pulse rates for the sample of people after running a race are shown in the stem and leaf plot. So now we're going to make our own box and whisker plot from this stem and leaf plot, okay? So the 5-number summary, again, is the minimum, the maximum, the median, or the second quartile, and the first and the third quartile. So the minimum and maximum are the easiest things to do. So we want to do those first. So I like to say that's like, we're going to do that. Number 1, find those first. So the minimum is, of course, going to be 68. And the maximum is 11 with a 0 after it, so 110. Okay, we'll do those first. Next, we have to find the median. We can't find the first and the third quartile unless we find the median first. So we need to first count up and figure out how many different data values we have here. So each leaf represents a data value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 19 values, okay? And don't know why I dotted that U. But if there are 19 values, to find the median, we need to take 19 and divide that by 2, which gives us 9.5. Now, what does that mean? That means that 9 values are going to be below. So 9 to the left, and then we'll have our median, and then there'll be 9 to the right. So really, if we bump this up to the next whole number, that would be 10. We're looking for the 10th value. So the median is going to be the 10th value, and this is going to be the second thing that we find. So we're looking for the 10th value. So we'll count up from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here's the 10th value. You can even circle it. It'd be good to circle it so that we can move on to the next step. Now, remember, you don't just write 6 with a median. That's 76, a pulse rate of 76. Now, the last thing you need to do is find the 2 quartiles. It doesn't matter which one you find first because we're going to find them the same way. So we don't use this median, okay? We only look at those below it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 values here. We're looking for the middle value. 9 divided by 2 is 4.5. Bump it up to the next whole number, so that's 5. 1, 2, 3, 4, 5. So that's the 5th value. So you can see there's 4 below the blue number, 4 above the blue number. So that's 70, a pulse rate of 70. And so that was the next thing that we found. We're going to find this also. Same thing at the top half. We have 9 values above the red median. So we want to find the middle of those values, which is again going to be the 5th one. So this one was the 5th value, and this one is the 5th above the 10th, so that's the 15th value. And so 1, 2, 3, 4, 5. So here's the one we're looking at here. So that is 88, a pulse rate of 88. Okay. So we're going to take those values and we're going to sketch a box and whisker plot. Now we have to be careful. We know the minimum is 68 and the maximum is 110. So I'm going to make my values go from 60 up to 110. So if I space them out, this would be like 70, 80. Now it's very important that these intervals are even, not like perfectly even. You don't have to get out a ruler, but pretty close to even. So you don't want to make a little squatty one because that won't represent your data. This is 100 and this is 110. Okay. So we know that the minimum is 68, so we put a dot at 68. The maximum is 110. Okay. If you want, you can put dots at all of them, and then we'll use those to make the boxes. So 70 then is here. 76 is probably right here. And 88 is about here. Now, these whiskers, you can make the whiskers, and then you need to make a box out of these 3 with a bar down the middle of the box. And there you have your box and whisker plot. Okay. All right. What I would like you to do in number 3, it says The given back-to-back stem and leaf plot shows the calorie content of different brands of potato chips and tortilla chips. What I want you to do is to skip the potato chips because that's that's the backwards box plot or stem and leaf plot. Sorry, and I want you to just focus on the tortilla chips. So I want you to do exactly what we did for the tortilla chips down here in the chart. Okay. So we're going to pause the video and I just want you to complete the 5-number summary for just the tortilla chips and then we'll come back and check it. Pause the video here. Okay, let's see how we did. So for the tortilla chips, the minimum is 110, the maximum is 160. And it is important, if you didn't notice, that there'll always be, I guess there won't always be, but there'll be a key down here. And so it means that the 15 in here and then the 0 over here means 150 calories. It might mean 15.0 or it can mean 1500. You just want to make sure you pay close attention to that key. So the minimum, maximum, okay, the median is going to be the 6th value. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 divided by 2 is 5.5. Round that up to the next whole number, so we're looking for the 6th value. So 1, 2, 3, 4, 5, 6. So that's 145. Okay, we're going to circle it. Then we find the quartile, first quartile, and there's 1, 2, 3, 4, 5 values below that 5. So we're looking for the middle one, which will be the 3rd one. So now there'll be 2 below it and 2 above it before you hit the actual median. So that's 135. And then for quartile 3, same thing. 1, 2, 3, 4, 5 below, or I'm sorry, above. There's 5 above, 145. And the middle one would be this one, so that would be 152. Okay, hopefully we did a good job there. Now, we're going to do all the exact same thing for the potato chips, but the potato chips get a little tricky because the stem is on the right and the data values, which are the leaf, are on the left. But when we write them out, we have to put them on the right. So I will get you started, and then I'll have you complete those. So the minimum here would be this value right here, which is not 0, 1, 12, but 1, 2, 0, so 120. So you have to just like switch them, okay? And then here, the maximum isn't 217, it's set 17 with the 2 after, okay? So I want you to pause the video and find the median and the first quartile and the 3rd quartile of the potato chips, and go ahead and put that in here. So pause the video here. Okay, so when we do the first quartile, 2nd, and the 3rd, we have to find the 2nd quartile again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's still 11. So we're still using the 6th value. 1, 2, 3, 4, 5, 6. So we have to be careful of a couple things. Make sure you're going from the lowest up. So we don't go here. We would count left to right like this because the lower ones are on the left. But when we're building the leaves away from the stem, the lower ones are on the right. It's all flipped. So 1, 2, 3, 4, 5, 6. So this is the 6th value. So that would be 155. And we've got 1, 2, 3, 4, 5 below it. Those are smaller. 0, 4. Go with those, not the 5. So we want to go with the 3rd one. 1, 2, 3. So that'd be 135. And then at the top also, let's go 1, 2, 3, 4, 5, 6. And wait a second. Sorry. See, I almost made a mistake there. We have to go from above the 5. So 1, 2, 3, 4, 5. So 1, 2, 3. This would be it right here, which should be 160, 160. All right, so I'm going to help you build just the scale at the bottom, and then I'm going to have you find or draw the two box and whisker plots and answer these two questions. So we know our lowest value is 110, so we're going to start with 110 down here. And we need to go up to 172. I'm going to go all the way up to 180. So put your scale as low as you can. I'm actually going to go down here so that I have room for both box plots here. So that's 110. I'm going to count up, so let's go like this. 120, 130, 140, 150, 160, 170, and I was off just a little, so I'm going to go right here for 180. Remember, they need to be relatively even. I don't even care if that line is straight right there. Just try to get these spaced out pretty evenly. Okay, so I want you to pause the video here. What you're going to do is write potato here and tortilla here, and you're going to put the potato box and whisker plot here and the tortilla box and whisker plot here. So I'm going to pause the video. You're going to pause the video here. Do your two box and whisker plots, and then see if you can answer B and C. So pause the video here. All right, let's see how we did. So potato, we've got 120, 135, 155, 160, and 172. So you can do your whisker in, and then this becomes the box with the 3 sticks, kind of. There's your box and whisker plot. Now for the tortilla, we've got 110. It's going to start all the way down here. Then 135, 145, 152, and 160. So whisker in, whisker out, and the box in between. Okay, so let's see how you did on answering these questions. Based on the box plots, on average, do potato chips or tortilla chips have a higher calorie content? So mostly you're focusing on the median, which remember is the second quartile here. So potato chips or tortilla chips, which one has a higher calorie content? That's going to be potato chips. Think about all that grease on potato chips. So the median calorie content for a potato chips is 155, which is 10 calories more than a tortilla chip. So because the median for potato chips is 10 calories higher than that of tortilla chips, they have higher calorie content on average. Okay? And what type of chip has more variability? So the spread of the data. Now, remember, we want to focus not on the maximum and the minimum, not the actual range, but the interquartile range. So the range, the actual range, 172 minus 120 would be 52 here, and here it would be 50. So the ranges are actually very similar, but The ranges, remember, include any outliers. So we want to focus on the IQR. So based on the IQR, okay. Now the IQR, remember, is just the range of the box. So we take the quartile 3 and subtract the quartile 1. So we've got 160 minus 135, which is 25. That's for potato. And tortilla would be 152 minus 135, which is only 17. And you can tell just by looking at the box that the box is smaller here. So based on the IQR, the variability is 8 calories less than that for, back that up, 8 calories less for tortilla chips than potato chips, which means that the tortilla chips, mostly their calorie content will they will all fall closer together than those of the potato chips. So you'll have some potato chips that have much more calories and some that have much fewer calories. Some that have, the same number of calories as a tortilla chip, in fact. But the range for those of potato chips can get much higher, as you can see, than those of tortilla chips. So they'll just spread more. Okay, there's more variability. So the size of the box between the first and the third quartile will tell you which has more possibility of being different, I guess.